Welcome to The Explainer, where we break down big topics. Today, we're jumping into something that's like the fundamental rulebook for all data: levels of measurement. Now, I know that might sound a little dry, but trust me, this is so much more important than it seems. All right, to get us started, let me throw a little puzzle your way. Why is it totally, completely meaningless to calculate the average of a list of phone numbers? I mean, really think about it. What on earth would that number even mean? Well, the answer's actually pretty simple. It's because some numbers, they're just labels. They don't actually count anything, they're just there to identify something. And that idea, right there, is the key to what we're talking about today. So the solution to our phone number puzzle has a name. It's called level of measurement. The best way to think about it is like it's the official rulebook for data. It's a system that helps us sort our information and tells us, hey, you can do this math, but also, whoa, don't you dare do that math. It'll just give you nonsense. Okay, so let's jump right in. We're going to start at the very first rung of the data ladder, level 1. This one's super straightforward. It's all about just putting things into different boxes or categories. And the fancy name for this is nominal data. So what are the rules here? Well, with nominal data, pretty much the only thing you can do is tell if two things are the same or if they're different. That's it. There's no logical order, no ranking. You could literally shuffle the categories all around and it wouldn't make a lick of difference. And here are some perfect examples you see every day. Take marital status, right? The categories don't have an order. Married isn't somehow more than single. And hey, look, there are our telephone numbers from the puzzle, see? They're just labels. That's exactly why averaging them is totally pointless. It's classic nominal data. Okay, time to climb up to the next level. Let's see how this all builds on itself. We're moving one step up the ladder to what's called ordinal data. And this is where we get our brand new superpower. We can finally put things in order. So yeah, now we have a ranking. We can say this is more than that or less than that. But, and you gotta listen to this part, here's the critical rule. You cannot assume that the distances between the ranks are equal. If you remember one thing about ordinal data, let it be that. And honestly, you see this stuff all the time. Think about any survey you've ever taken. Agree, neutral, disagree. Yeah, we know agree is higher on the scale than neutral, but is the gap in feeling between agree and neutral the exact same as the gap between neutral and disagree? Probably not, right? We can't know for sure. It's the same deal with school grades. And that brings us to the key question that shows you the big limitation here. Is the difference in actual knowledge between an A student and a B student really the same as between a B student and a C student? Almost definitely not. And to get around that problem, well, you guessed it. We've got to climb to the next level. And here we are. We've made it to the top of the data ladder. This is metric data. This is where the distances between our numbers finally mean something. They're precise, they're equal. This is the level you need to do all the really powerful statistical stuff. Okay, so even at the top, metric data splits into two different types: interval and ratio. Now, they are almost the same. For both of them, the distance between the numbers is equal and it means something. The only difference, and it's a huge one, is the zero. An interval scale has a zero, but it's kind of made up. Think about temperature. 0 degrees Celsius doesn't mean there's no heat, right? But a ratio scale has a true absolute zero. Like 0 minutes in a race means 0 time has passed. It's a real nothing. Okay, you've seen the rule book. Now it's time for the fun part, a little pop quiz. Let's see if you can put this new knowledge to work and figure out how to classify some real-world examples. First one up, an IQ score. So, think it through. Can you measure the distance? Is the difference between 100 and 110 the same as 110 to 120? And here's the big one. Does an IQ of 0 mean someone has absolutely no intelligence at all? And the answer is metric. Specifically, it's an interval scale. Yep, the distance between scores is totally meaningful. That 10-point gap is always a 10-point gap. But that 0 point, it's just a theoretical thing. It doesn't mean a true absence of intelligence. So no true 0 means it's gotta be an interval scale. Nicely done. All right, ready for the next one? Let's say a hospital rates patient care as good, fair, or poor. What level of measurement is that? If you said ordinal, you are spot on. There's a clear order, right? Good is definitely better than fair. But again, we hit that same old problem. Is the jump from poor to fair the same size as the jump from fair to good? We have no idea. The distance isn't measurable. We just know the order. Okay, last one for the test. Something super straightforward. Measuring an apartment's living space in square meters. What have we got? Yep, this is a textbook example of a metric ratio scale. The distances are perfect. 20 square meters is exactly double 10 square meters. And the most important part, it has a true 0. 0 square meters means you got it, no space at all. That's what makes it a ratio scale. So why does any of this matter? I mean, why do we just climb that whole data ladder? Well, this quote really nails it. Figuring out your level of measurement is step 1. It's what tells you what kinds of charts you can make and what kinds of conclusions you're even allowed to make. If you mess this part up, your whole analysis, everything that comes after, could be just wrong. Look, this isn't just some boring theory. It's a super practical tool for you to use. It helps you think critically about any data you see. So I'll leave you with this question. Now that you know the official data rulebook, how are you going to look at the next chart, the next statistic you come across?